I will officially welcome you all to this biodiversity webinar. We're really pleased to have actually a so big audience today. And if you have already joined some webinars of biodiversity, you might have already learned something about this project. And you might have noticed that today we decided to organize a webinar also with other initiatives related to the digital twin environment. So specifically, Destination Earth, Climate DT, Terra DT, Intertwin, and DT Geo, because we also wanted to expand a little bit our view and also highlight how biodiversity can also cooperate with other initiatives and further let's say, also support the development of the digital twin. My name is Rita Giuffrida, and I am the Communication and Dissemination Leader for Biodiversity Project, and today I will be moderating this webinar. The agenda for today is here on my next slide, and you can see that you will actually have the opportunity to learn more, a lot about the digital twins. And in particular, you can learn more about the opportunities and limitations of digital twins, and also the opportunities that are also offered by cooperating. You are free also to ask any questions to any time to our experts. Today, feel free to do so by using the Q&A chat on Zoom. As I was mentioning at the very beginning of this webinar, we are very pleased to see that this webinar attracted a lot of people. We actually saw that we had more than 90 people that registered, and these people are coming from 24 countries in the world, mostly from the research environment. And we really hope that today you can learn something more about the DT realm. I would like also to provide a little bit of context of why we decided to organize this webinar also with other projects. And I will do so by showing some numbers that most probably will also speak for themselves. And in particular, what we would like to share with you is also the impact that climate change is having on biodiversity and how this could be also, let's say, solved by science and by research. And so how the DT can play a role in this. In particular, let's say one of the latest research shows that up to 50% of the species could be heavily be impacted by climate change because all their suitable conditions could be, let's say, heavily impacted by 2100. And this is mainly due to greenhouse, a higher amount of greenhouse gas emissions. And in particular, also in one of the latest studies from the IPCC, it is also stated that if the temperature of, let's say, our world rises from 1.5 to 2.5 degrees, then this will really heavily impact all the species, let's say, actually almost 20 or 30% of all the species could face extinction. So the numbers are actually quite worrying, I would say, and we know that there are already some solutions in place. And today, as I was mentioning, we would like really to show you how the digital twins can play a role in this. After this very short introduction, I would like to also let you discover a little bit more who are all the initiatives behind this. And in particular, I will pass the floor to the first speaker for today, Thomas Wienen from ECMWF.
Thank you, Rita. So indeed, my name is Thomas Wienen. I work for ECMWF, and I'm the Technology Partnership Lead for Destination Earth. So I want to quickly introduce Destination Earth in 2 slides. Now that's not so easy. Luckily, Jenny Konkanen will talk after me, and we'll talk about climate change adaptation, digital twins. So I only have to cover half of the Destination Earth. So Destination Earth is an initiative directly funded by the European Commission to move into production towards 2030, a service that will basically provide digital twin capabilities for Earth system digital twins. Initially, we are targeting 2 main digital twins. the one on weather-induced extremes, and the other one on climate change adaptation. So the interesting thing about these digital twins is that obviously the one on extremes is operating on quite short timescales and runs globally at a high resolution, where the climate change adaptation digital twin runs at a comparable resolution also globally, but of course covers a much larger time window. And what's interesting about both these digital twins is that we link these digital twins directly to impact sector applications that can then sort of assess the impact of extreme events, but also on climate change. And these digital twins, obviously, like digital twins are designed to do so, are there to capture specific adaptation measures and try to assess the impact of the adaptation measures that are put in place. And the same is being done also for climate. So what can droughts, what are the effects of droughts and heat waves on how basically will these evolve in future climates when the temperature will be higher. Next slide, please. What I want to emphasize a little bit more, because we will have a lot of talks about digital twins, is the role of AI. So in Destination Earth, AI is becoming more and more important. Obviously, ECMWF is heavily developing its own AI model for the weather forecast for the atmospheric part. But in the coming period in Destination Earth, we're gonna also develop a lot more AI components for other Earth system components in Destination Earth, with the aim to move towards a full Earth system AI model for Destination Earth going forward. At the same time, we're also pushing and creating initiatives around AI models for the impact sector, so that we move more and more in towards a full AI-supported AI implementation of Destination Earth. And that will also allow us to use AI methodologies and methods for understanding and interacting and operating on Destination Earth. As you can see on the right-hand side, where we will leverage AI capabilities to interact with the system, with the models, and also with the data. All right. That was all I wanted to say.
Thanks a lot, Thomas, for providing a brief overview of Destiny. Then we can also hear something more about Destiny during the panel discussion. So now instead, I will pass the floor to Jenny Kontkanen. I hope that I'm pronouncing your surname correctly, from CSC, who instead will present two initiatives, Climate DT and Terra DT.
Thank you very much, Rita. So yes, like I said, I'm Jenny Kontkanen from CSC IT Center for Science that is in Finland. And I will first introduce or talk a little bit more about Destination Earth Climate Digital Twin that Thomas already mentioned. So Climate DT is one of those high priority digital twins of Destination Earth, and it combines high resolution global climate models with impact sector applications to produce information that can support climate adaptation actions. Key novelties of Climate DT include that it provides multi-decadal climate projections at very high resolution, so at 5 to 10 kilometer spatial resolution with 3 coupled climate models. Climate DT also includes first ever operational capability for providing these climate projections at regular intervals. And also Climate DT includes capabilities for addressing what-if questions. That is something that Thomas already mentioned. And what is important novelty of Climate DT is also that it provides actionable information for different sectors. And this is made possible by bringing these climate models and impact sector models within the same workflow on the same computing systems. You can change the slide. And so how Climate DT then can support climate adaptation actions is that it provides information on climate change impacts at local and regional scales with a global perspective. So this means that the Climate DT can help to answer to questions like, how will frequency and magnitude of different extreme events change in the coming decades? how will climate change impact different sectors? So, for example, renewable energy, agriculture, urban planning, or water management, and also what influence different policy decisions can have on these impacts of climate change. And so different type of users, ranging from scientists and experts to policymakers and even private citizens, can access climate DT data from the Destination Earth platform. The first set of simulations is already available there. And just the last thing that I want to mention is that the climate DT is implemented by a partnership that we at CSC lead, and that involves 12 European organizations, and it is implemented through a contract that is procured by ECNWF. So we, of course, also collaborate a lot with ECNWF themselves. So I can move on to the second project that I'm representing here today, and this is very much actually linked to climate DT and Destination Earth more generally. So this is Terra DT, which is Horizon Europe funded project which aims to enhance Destination Earth infrastructure. And this is done by 3 ways. So first of all, we develop new digital twin components on cryosphere, land surface, and aerosols to improve these climate projections that are done within Destination Earth. We also developed impact models that provide user-relevant information linked to sea ice, land ice, forests, and urban areas. And finally, we developed new software components that enable making Destination Earth infrastructure more modular and scalable. So you can basically see here these basic ideas. So we have these core climate models that are same as in Destination Earth. Then we have digital twin components on the middle, and then impact models on the right. And we utilize EuroAPC computing systems and Destination Earth infrastructure. You can change the slide. So Terra DT started very recently in January this year, but it will last for 4 years. And by the end of the project, we aim to integrate our main developments as part of the Destination Earth infrastructure. And Terra DT is put together by a consortium, including 18 European organizations, and is coordinated by us at CSC. Thank you.
Thank you, Jenny, also for actually presenting 2 initiatives instead of 1. So now I said the third speaker will be Gabriela Zuchim, always from CSC, who instead will present the BioDT project.
Hello, everyone. Thank you, Rita. Thank you, all the organizers, all the panelists for being here today and the audience. My name is Gabriela Zuchim. I am the scientific coordinator of BioDT, and I'm based at CSC, the IT Center for Science, which is a research infrastructure institution based in Finland. So in BioDT, which stands for Biodiversity Digital Twin for Advanced Modeling, Simulation, and Prediction Capabilities, we have 3 objectives, which is to build and deploy prototypes of biodiversity digital twins, to support interoperability of data service and research infrastructures, and to ensure interoperability of BioDT with other European Union initiatives. The project is in its 3rd year now, and what we are building is that we can combine high-performance computing and cloud services to deliver prototypes of digital twins in a laptop. So easy to use, user-friendly deployment of biodiversity digital twins. And for that, CSC is the coordinator, and we have a consortium with 22 different institutions. And next, please. And we build on top of 4 different topics, which are species response to environmental change, ranging from grassland modeling, forest biodiversity dynamics. Then in the topic of genetically detected biodiversity, we are addressing crop wild relatives, distribution and stressors, phylogenetic diversity. And then we are also focusing on the dynamics and threats from and for species of policy concern, which are mainly the invasive alien species, or modeling the level of invasion of species in Europe, and also species interactions with each other and with humans, covering 2 main topics, which are the disease outbreaks and then honeybees in agriculture landscapes. So to give a very practical example of what has been done in BioDT across those 10 topics that I mentioned before, I picked only 1 to show what kind of deployment is being done. So there is a web page where you can see the apps that are being developed. And if you pick, for example, the honeybee case, you have an output, so a user-friendly graphical interface in which the user can select different areas and simulate according to their practices, the size of their colonies, and how much honey can be produced in different places in Germany. So this is a very practical and example on how policymakers can use the products that are being produced in BioDT. Thank you.
Thank you, Gabriela. Now instead I will pass the floor to Andrea Manzi, who will instead present the InterTwin project.
Yes, good afternoon. I'm Andrea Manzi from the GI Foundation, and I'm the technical coordinator of the InterTwin project. So I cannot go much in details today, but I would like to basically introduce the project, which is a bit different from the others initiative because our focus mainly is on the development of digital twin engine for science, which basically is a platform co-designed with the large spectrum of use cases that are coming from both from the environmental scientists, but also from physics. And this interdisciplinary digital twin engine is mainly focused on providing tools for digital twin developers. So we have like different layers. As I said, cannot go in details, but we have developing from infrastructure module, core modules, and then thematic modules that can be developed tailored to the needs of digital twin applications that is on top. If you go to the next slides, just to mention we have the project started in September 2022, so we are entering now the last 6 months of the project because we'll end in August this year, and we put together like many participants in different areas, so providers of resources coming from cloud, HPC, and HPC, the technology providers, which of course have implemented the core and the infrastructure models, and then we have like different community representatives coming from different 5 domains that are developing the digital twins application and thematic modules. Here, just a picture of different use cases which we are using to validate, of course, the development of the digital twin engine. So as I said, we work both on environment and physics with different digital twins prototypes. Thank you.
Thank you, Andrea. And now I will pass the floor to the last speaker that instead will present the DTGEO project, so Ramon Carbonell, and the floor is yours.
Thank you very much, Rita. Thanks for having me here. I'm basically the coordinator of the DTGEO project, and I work at the National Research Council in Spain. And we are coordinating a number of 13 different institutions devoted to this project. This project, this is what you have on screen, is just the diagram of the actual project. What it's important here is that we have 4 main objectives. The first one is to deploy pre-operational prototypes of digital twin devoted to geophysical extreme situation. What do we understand with geophysical extreme situation is basically hazardous phenomena like volcanic eruptions, tsunamis, earthquakes, and we also included a anthropologically induced extremes in order to address induced seismicity for any sort of human activity, example, mining and things like that. And basically the idea is to generate a number of digital twin components because, as you can see, each of these phenomena has different associated phenomena attached to it. And the idea is to have a tool to aid early warning, provide some forecast, and basically address the hazard assessment across multiple time scales. So the idea is to have the flexible framework that will account for all the fairness or fair validation of all the digital assets, data, and software, and basically all the outcomes associated to it. And the idea is to have these different utilities or digital twin components that could be integrated either to a service provider like EPOS, European Plate Observation System, or some of them are definitely be included in the Destination Earth. And also we need for that a direct connection with Euro HPC or high computing infrastructure to run all the software that we have. A key feature that I think this DT component has, the digital twin has, is the operational validation or verification of the DTs, in which we have 13 different site demonstrators in which we are devoted right now during the development of the project. We are not reinventing the wheel. We are using existing structures, and it's already, you have them on the left side in here, some of the issues that are contributing into the main project. If you can go to the next slide. Okay, here is the different site demonstrators that we are using. They are color-coded, and as you can notice, there are more than one for each of the DTCs. And we will see that this is very important in order to follow or be follow the directions within the European Act for the ethic usage of AI, as AI is an important part of some of the processes that are involved in the different workflows. And on your right side have the, let's say, our sustainability plan to have some of the outputs or outcomes of DTGeo going directly into Destination Earth, others directly in services, into other options like Euro HPC or EPOS. They obviously will benefit of some of the inputs of other European funded projects, as you have here, TEAS and GeoInquire. I think this is all from my part.
Thank you, Ramon. And thank you also for all the other speakers, for all the experts that we have today at the webinar, also for sharing some initial insights of all the initiatives that are contributing to shaping the digital twin of the Earth. So now I would like also, let's say, to bring back all the experts again, because we will start to officially, let's say, kick off an official, let's say, a panel discussion, where I will also ask you some questions that could also help the audience understand a little bit better what is the impact of digital twins. And Thomas, I will actually ask you the first question. That is, let's say, also a little bit more general. And in particular, it says, how can digital twins essentially mitigate the biodiversity crisis? If maybe you can give an overview from the Destiny perspective.
So I think fundamentally, a tool like a digital twin itself is not in a position to mitigate anything. It's a tool that you can use to evaluate certain scenarios. So it's more about understanding the effectiveness of certain policy decisions, right? So in that sense, if the tool is used right and the right questions are being asked to the tool, and the tool should be in a position to give answers that are meaningful and can be directly applied for these mitigation actions. So in that sense, I do believe that digital twins are an excellent tool for this, because that is at the basis of their capabilities to allow for this interactivity and for this running of hypothetical scenarios, given the fact that you have an underlying model that represents your asset or your reality, in this case, your biodiversity domain, and also observations and data flowing directly into this model to understand if your actions actually are meaningful. So in that sense, I think, yes, the tool is definitely fit for purpose, but the tool itself will not act on its own in that sense.
Thank you, Thomas. And in fact, I would like also to hear from Jenny. If you, as I mean, you're also involved in the Climate DT initiative that is strongly connected to Destiny, also Terra DT, which is a project. If, let's say, from your point of view, in which ways could the projects you're involved, let's say, in also mitigate the biodiversity crisis with the, let's say, digital twin tools that are developed in the context of these projects?
Yes. So I totally agree with Thomas is saying about that. Of course, the digital twins themselves cannot do this mitigation, but what we aim here with the climate DT, both climate DT and Terra DT, is that we can provide tools that provide actionable information. And more specifically, with climate DT, it provides information on how climate changes in the future, and at quite high spatial and temporal resolution. And of course, that also has implications on biodiversity. So for example, if the frequency of droughts changes, that can influence many species. Then when talking about Terra DT, in Terra DT, we also more specifically will improve understanding of how land cover and vegetation will change in the coming decades. And that is also very relevant information for when thinking about biodiversity changes. But of course, then if we really want to understand that what happens for biodiversity, we have to have models that are really focused on biodiversity, or something that is currently already being developed as part of the BioDT, for example, and have this connection between these digital twins providing information on climate and then these digital twins providing more detailed information on biodiversity.
Thank you, Jenny. And it was also nice to see that actually the project you're working on is connected also to the work that existing projects are already doing. So it is really a way also of bringing together best practices and then also try to exploit them in future projects. Thank you both, really. Now, Gabriela, I would like also to ask you a question maybe for the, let's say, from the BioDT project. If, let's say, from your opinion, also considering that the project is also very close to the end, what in your opinion would be the future of utilizing digital modeling tools? You can provide either examples for BioDT or also in general.
Okay, thank you, Rita. Yeah, indeed, BioDT will come to an end, but the legacy of BioDT will be felt in the future. And in terms of the practical tools that we already developed, as I mentioned, they are in prototyping stage, but they can provide solutions to simple yet extremely important questions. For example, trying to predict the level of invasion of alien species in Europe in different areas. This would allow us to act timely before the invasions actually happens. So the unprecedented contribution of this digital twin approach in the biodiversity realm, I believe it's the fact that we can use near real-time environmental and biodiversity data and have this sandbox to test the different policies. This allows relevant and timely policymakers to make scientifically based decisions. So in that sense, the future of using digital modeling tools is going to be growing and growing. We will observe growing and growing importance of these digital modeling tools if we want to do more meaningful decisions, develop alert systems. And specifically in the BioDT approach, having this possibility of sandbox environments for testing different policies and land use approaches. And for that in BioDT, we have been leveraging the Euro high-performance computing capabilities, for example, the LUMI, that is one of the fastest supercomputers in the world. And that allows, by connecting the biodiversity and ecology researchers and communities modelers, to upscale biodiversity models to run timely and with this unprecedented amount of data. So we are aiming towards, we're being driven by the fact that we can have better modeling, more accurate predictions of how the biodiversity will be affected. For example, as Jenny was mentioning, the droughts and the climate changes in general. So in a nutshell, the future is that we will be more and more utilizing the digital modeling tools. Thank you.
Thank you, Gabriela, also for sharing this insight. It was actually interesting to hear that actually, yeah, the future digital twin is not only related to science, but it can also have impact on policies. Because obviously, I mean, and if with our work, we can also, let's say, provide any, let's say, recommendations from this point of view, then obviously we could potentially also hope that policies that will protect the biodiversity would also be, let's say, developed. So I would like really to thank you all again. And now, I mean, we are actually moving towards the second part of the webinar. And in this second part, we would like, first of all, to interact a little bit with the audience. Here, I don't know if you have ever used Menti before, but it is a pretty easy tool to use. You can access it in two ways, either using the QR code that you have here in front of you in this slide, or by going to the website menti.com and then press the number that you have here in the slide. So 51455951. We have a lot of fives in this code. And then you can also join the discussion. Now I will stop sharing the screen for a couple of minutes because I will allow my colleague Anya to also share the Mentimeter link with us, so you can all see the questions we would like to ask you. They're not very difficult questions. They will just help us understand a little bit better what is your understanding in, let's say, of digital twin, and if you are using also all these tools. Okay. And okay, I will actually reshare again my screen, and hopefully you can all see my screen now. Okay. And we also see that some people started to join. So that's, I mean, also to access this platform. So the first question that we would like to ask you is, in your opinion, what could be the most effective ways to reduce the risks of natural disaster? Please use very short replies, meaning that you can either use just one word or a very short sentence. And I see that actually one person has already replied, and they actually mentioned that it would be nice also to elect a competent government. Okay. I don't know if anyone else has any other comments, let's say, more related to science or other. Okay, Gabriela, I see that you are raising your hand.
Yeah, I can say that we in BioDT or any digital twin initiative, we cannot influence what the government is being elected, but we can influence providing scientific-based information for the governments to take the right decisions.
Okay. I also see actually we have a participant that has raised his hand. I don't know, Claudia, if you would like also to comment here, I can allow you to talk. Otherwise, you can also include questions. Okay, by the way, my colleague Anya is mentioning that we have got more responsive than the one that I'm sharing now. So I will just stop sharing and I will let her share the screen. Okay, so
thank you, Rita. Sorry about this.
No problem. Okay, yes. So, okay, so we got the, let's say, more comments, mostly, let's say, about the funding, or also improving all the predictive modeling, and also, let's say, to also have a multi-stakeholder. So here I believe that people that included this comment is mostly about the fact that we should, let's say, also include more people. Let's say, so then not only researcher or let's say policy, but let's say also expand a little bit the area here. Then also a way to receive information faster. Okay, and then also have preventive policies. Okay, so thanks all. So maybe Anya, I can ask you to move to the next slide. Okay, so this question instead is about how can we extend the knowledge and ability to utilize digital twins? Okay, so have friendly interfaces. Okay, that's actually good because we develop a digital twin that is then hard to, let's say, to use. It would be a little bit difficult to have it. Any other ideas from any other people here? I would say that also the cooperation, let's say, with all the different digital twin projects, like, for example, what biodiversity is doing, but also all the other projects would surely also help with this. Okay, we have also another relevant comment that is about trainings and education. Okay, training events. So here we have more people that agree on this. And then easy access to common hub. So it is a little bit also related to the friendly interfaces we were discussing before. Okay. And then maybe Anya, we can move also. Okay, sorry. We got also other comments that are about the standardization, okay, of data mostly because with digital twins, obviously, we are managing a quite high amount of data. And then also custom, let's say, some tools that are that can be used also for different user profiles. So not just have one that fits all, but also have some say flexibility in this. And now we would like also to share we would like to ask you one last question that it is, I mean, mostly for you, and we would like to, let's say, we would really like to understand if you will be also interested and involved in adopting the digital twin tools. So not only, let's say, both the ones that have been presented today, but also others that could be potentially developed in the future. And also how you could utilize them. Okay.
Many people of the audience is also already involved in these initiatives and developing and maybe even using them.
That's true. So that's also why. But anyway, in case you would like also to be involved in testing the digital twin tools, very soon they will be also released. So for example, if I bring the example of biodiversity, by let's say by May, you could also test them. Some of the prototype digital twins are already available now. So it could be a good opportunity also to understand a little bit better how they work. So thank you, Anya, for sharing the screen. Now I will go back to the presentation and I will move towards the end of this webinar. And actually here, we would like to have again all the speakers, let's say all the experts invited today, also to have a second round of questions for a panel discussion. This will be mostly about how all the digital twins can cooperate together. And in particular for the first question, so how can collaboration between the digital twins be further supported and strengthened? Maybe Thomas, I would like to ask you this question to you because as Destiny, maybe you could also maybe provide some feedback and useful tips on how it can be done.
All right. Well, first of all, I would like to stress that we are already doing a lot in this domain. So, for instance, ECWF is part of the biodiversity project, part of the Intertwin project. We're in the advisory board of DTGeo. We have a lot of discussions on interoperability between Destination Earth and these other digital twin initiatives. So we're not doing that bad, I would argue. Then also we sort of started roughly at the same time. So we are basically evolving side by side, learning from each other, influencing each other. So also there, I think that is really, really important. Another thing that we have been doing, and I think which is really important, is we have, from a technical perspective, also really looked at the different architectures of the different projects to try and understand how we can align on an architectural level and come to some common understanding of a high level architectural view of digital twins and what components make up digital twin and how we can interoperate between these components. And we also started, but that's really at the early stage, to talk about a common and shared glossary terminology. So if we describe a certain component, we talk about the same thing. So I think that is really important between these communities that are quite diverse, that we are evolving side by side, that we are involved in each other's initiatives, that we are aligning on architectural principles, that we're aligning on glossaries and so on. And that will continue going forward with new initiatives like, for instance, TerraDT. We will have the same dynamics. And I'm really positive that this will work out very, very well going forward.
Thank you, Thomas. Anyone from the project here would like also to say something on top? I don't know, Jenny, if you could also mention something of TerraDT as, let's say, it was also the example provided by Thomas.
I think Thomas was covering it very well, so I can totally agree. So this collaboration, like Thomas was saying, can happen on different levels. So there can be this kind of really technical integration, then there can be more like conceptual discussions. Maybe one only thing that I could add here is that one good opportunity is also to utilize these kind of let's say international forums and organizations for this as well. So I want to mention that, for example, we have at CSC, we have initiated an interest group on digital twins in RDA, which is Research Data Alliance Organization. So these kind of like discussions really within a larger community on, for example, on these standards and possibilities for interoperability, they are something that could be also utilized. And we also in TerraDT have a separate task on this kind of international collaboration on creating standards for digital twins. So definitely this is a very important topic so that we can really benefit from all these different initiatives and projects.
Thank you, Yanni. And then, I mean, we have also, let's say, discussed a little bit before about the technicalities of digital twins and also about the complexity of a digital twin, let's say. Yanni, for example, before was also discussing about the standard that should also be used to develop it. So we know that we also have some challenges, let's say, about let's say, developing a digital modeling data sets. So here, maybe I would like also to bring Andrea and then Ramon. And I would like also to understand from you, let's say, what are your feelings on this from an intertwin and then DTGeo perspective?
Yeah, from intertwin, I mean, I think the main problem, but not only from intertwin, I think it's interoperability. So of course, you know, the usage of datasets that are, you know, coming from different initiatives with different format standards, you know, different metadata that are used for different, you know, purposes. Yes, of course, I believe this is the main issue here. And of course, you know, and then, you know, apart from this, of particular, you know, cases of digital twins, which are based on data-driven models, which are based on training of existing, you know, data sets. Of course, the amount of data and the size, which is basically sometimes is, you know, it's a problem when you want to share, you know, data between initiatives and to build, you know, and to make use in digital modeling. So I believe this is the main issue that we are seeing and we have seen during the project, but I believe this is common to other initiatives.
Thank you, Andrea. Ramon, are you also experiencing the same type of
I'm moving along the same lines. In my view, the bottlenecks are basically data handling, metadata harmonization, data interoperability. I mean, this is very important. At least this has come up already in some of our thematic cores. Let's say you use volcanics and you want to evaluate the ash distribution within an ecosystem, which that would be an interaction between BioDT, for example, and DTGeo. Then these things, data-related issues, become even worse. So I think there's further work needs to be developed within interoperability, And obviously, these things affect fairness principles. So I think that that's the main issue here. It's basically using the data with different, even within the different DTs that we are developing within DTGeo, but then if we are going to interact with other DTs, which is the ideal, things are going to be, I think this sort of issues will be worse. But obviously we have to put an effort in there. There's a future way of research in that line.
So mostly, I mean, hearing from you, the biggest problem is really to make all data interoperable, because yeah, they are actually in different formats, different sites, etc. So it is never easy. And it was actually nice, one that you were also mentioning the point on fair data, because all the fairness of data is always a complex topic, let's say. It is not so easy. In theory, let's say it should be, but then when you go in practice and manage a so big amount of data, it is never easy to make them fair. So I would like really to thank you for sharing these insights, and I would like actually now to ask all of you, so all the 5 speakers, also to share some insights about I mean, what are the next steps on your project? So if you can share also, let's say, a few lines about what you are expecting to do in the future. Gabriela already mentioned something before about biodiversity, but maybe we can also say a couple of few words, final words now. Maybe Thomas, I will start with you, and then I will pass the floor to the other speakers.
Well, thanks, Rita. So as I mentioned before, so for us, next steps, we're going to focus a lot on AI, machine learning. That is, for us, it becomes really important also to make the models much more interactive than they currently are. I mean, one of the challenges that we currently have is that these models are very expensive to run. And we already see, for instance, in our atmospheric machine learning models, or AIFS, running a forecast of AIFS can be almost like 1,000 times more energy efficient than traditional physics one. Also runs much faster. So these are kind of trends that for us are really important, that we're heavily investing in that one. The other thing, of course, Destination Earth is moving towards an operational state, so we're investing a lot in making things more operational. And it also means that the engagements we have with other digital twin initiatives are really focused on that one. So yes, we're working on making you part of Destination Earth, but there are definitely also a lot of operational challenges associated with it. So that will also absorb a lot of our attention going forward.
Thank you, Thomas. Jenny, what about climate DT and Terra DT?
Yes, so in climate DT, we are now currently, it's currently the second phase of the project, and now we are at the point where we are just starting the first so-called operational simulations. Like Thomas mentioned, we are also, as climate DT is part of Destination Earth, we are now really starting to move more and more towards like an operational system. So this means that then, let's say in summer, there should be a new set of simulations that is then available to all the users through the Destination Earth platform. Of course, in climate DT, we also do further development on the system, and this includes also using different AI approaches, for example, and increasing capabilities for interactivity. Then about Terra DT, the project just started last month, so we are of course now mostly focusing on kicking off everything, and our goal is now that during the first year we would get then kind of the first versions or first prototypes of different components. So this includes the different digital twin components, different impact models, and also different interfaces.
Thank you, Jenny. Then maybe I will pass the floor to Ramon.
I just have 3 words. One is the interfacing of the different geophysical extremes, like, for example, interface earthquakes and tsunamis, or volcanoes and tsunamis. The other word would be integration of DTGeo components with DTs of other disciplines, like what I mentioned before about the ash dispersal and the ecosystem response. And perhaps the last one, and probably one of the most important, is the sustainability of the systems. And at this point, I mean, we are developing all this, and we are aiming to transfer this to target European scale research infrastructures like TEPOS, ERIC, or some of them hopefully is going to be integrated within Destination Earth. I think these are the words that I would pinpoint the relevance to.
Thank you, Ramon. Andrea, what about InterTwin?
Yeah, so as I mentioned before, we are entering this last 6 months of the project, which and we are basically in March releasing the final release of the software of the digital twin engine, and then this will follow with the final integration of the digital twin applications that we are developing, so the demonstrators. So basically, this is what we do from a technical point of view. We are also organizing our final event in June, which will be co-located with a conference, GI conference, which we are organizing now. And of course, also sustainability point of view, understanding, what are the components that we have been developed, which will be included in our portfolio of service in AGI, and so the components that are part of the DTE. And of course, as I think everyone would like to understand the possibility to extend these developments in the context of the project or initiative in Europe.
Thanks, Andrea. And Gabriela, what about BioDT?
Thanks, Rita. In BioDT, we have a few months left. We are focusing now in launching more of the PDTs. Many of them are in the productization line now. They are almost ready to be launched, so we are focusing on getting them ready for launching. 2 were already launched, and there are others very close to it. Some might come next week, the others in the following weeks. Other aspect is that we are focusing on the sustainability of these prototypes, and this, as was mentioned by Andrea, it involves interoperability and several technical solutions that has to be done, and we are improving on that and discussing with the Destiny. Also, I should mention the LifeWatch ERIC initiative is also part of the sustainability plan of BioDT. We are also, since we now have several outcomes and products, we are investing in training and communication. For example, next week there will be a hackathon and a BioDT school happening in Italy, Lecce, with that data scientists, postdocs, postdoctoral researchers, PhD students. And also we have an open meeting that will be in the 3rd of April in Rome, and it will be about the BioDT in the Destiny landscape. So welcome everyone. Please, for more information, visit the biodt.eu page, and you can register from there. Thank you.
Thank you, Gabriela, and thank you everyone also for, let's say, summarizing all the next steps that your initiatives and projects are going to bring forward in the, let's say, next months or even years. And then I would like also to share with you, also to conclude a bit this webinar, some useful links that we have summarized here in one slide. They seem, let's say, later on we will also make the slides available online, so you can also have a closer look. But more or less, you can find some general information about the different initiatives or some more specific materials, like, for example, training documents, or, for example, also any platforms to access the data of the different DTs that we have here. Now, we have, just a couple of minutes, let's say, left for this webinar. And now I would like to pass the floor to my colleague Anya, who would like also to summarize a little bit the most relevant topics that were discussed today.
Thank you, Rita. Can you see my screen?
We can.
Perfect. Again, thank you all for your time, and thank you to the panelists for showcasing their beautiful digital twins and kind of seeing what has the work that has been done in the past and what can we look forward to in the future. I apologize for the very hectic notes. I was taking them as you were speaking, and it's really great to see all the progress that has been made. And maybe this is something for all of us to reflect, that even though we have various DTs, we're all working together to collectively enhance climate monitoring and disaster predictions and ensure that environmental sustainability can happen through the use of digital twins and AI. I would just like to say that these slides will also be available to you after the webinar, so you can also explore and see how you can stay in with the updates from different DETs. As you can see, we have highlighted some areas of focus. For instance, for DT Geo, this was the geographical extremes that they're monitoring in their pre-operational prototypes that they're developing. Intertwin is utilizing open source digital twin engines and is trying to promote open standards when developing digital twins. We also have a new project, which is TerraDT, which recently started and is utilizing the cryosphere, land surface, and aerosols in developing those digital models as well. And we would like to highlight the various Destination Earth prototypes that they're developing, including Climate DT, which combines various high-resolution global climate models and has managed to actually have and kind of create climate projections up to 5 to 10 kilometers of a resolution and really answer those what-if questions. And maybe just to kind of sum it up, what have we managed to actually answer the question at the beginning of the webinar, which is, can the cross-use models actually help in climate mitigation? And the answer is directly not. There's not such a magical solution that can just mitigate the risks, but it helps with the assessment and the effectiveness of policy decisions and actually enabling a well more thought approach to doing policymaking and helping develop mitigation strategies. And for the next steps, just to keep it short, is for all of these projects, it's actually developing various sustainability models. For some of them, it's also ensuring that there's interoperability amongst various data. And one of the ways we can stay connected is actually to utilize the diverse community that we have through various networking events to continue with the alignment on different architectural principles that are being developed through the DTs. And again, staying in touch and ensuring that the messaging and the concept of all DTs are aligned. Now, I was very glad to see that Gabriela has already shared what the BioDT is planning to do next. One thing I would also like to add alongside the final event that is happening in Rome in April is also the final webinar, which is still to be decided in terms of the date, but will happen in May. And this is where we can actually present the final prototype digital twins, including the final BioDT platform. So that's all for us today. And if you have any questions, I'll stop sharing the screen now. And please do write any comments you might have or any questions for the panelists. We still have 2 minutes. So that's great to hear. And thank you.
Thank you, Anya. I believe that we can also close the webinar now a little bit before. And we will, I would like also to thank again all the speakers and also all the attendees for joining the webinar today. As I was mentioning, the recording will be made available, so you can also have a look again of and let's say listen again to all the discussions that we had today. And let's say from a BioDT side, I hope to see you again either at the final event or the webinar or to both events. All the information will be made accessible on the website. So enjoy the afternoon, everyone, and see you soon. Bye-bye.
Thank you.
Thank you. Bye.